In this set of notes, we're going to learn how to graph a line using slope-intercept form. We've already seen graphing lines using Desmos graphing calculator or graphing by making an input-output table. Today we're going to find a faster way to do it. The first thing we need to do is make sure we can identify the slope and the y-intercept from an equation written in slope-intercept form. Slope-intercept form is when y is isolated, and then you can easily identify the slope and the y-intercept. So slope-intercept form is y equals mx plus b. The main thing to know is that y has to be isolated in order for any of this to work. Once y is isolated, we can then identify the slope of an equation, which is m, and m is always the coefficient of x. And this means that it will always be the x multiplier. So to find the slope, you're always going to be looking at the number that's multiplying x. The b value is our y-intercept, and that's always going to be the number that's being added or subtracted at the end. If it's positive, that means our y-intercept will be up on the y-axis, and if it's negative or if it's being subtracted, that means it's going to be negative. So first, let's take a look at some equations that may or may not be in slope-intercept form and see if we can identify the slope and the y-intercept. So the first thing I notice about example 1 is that y is isolated. So this means that my slope, as mentioned above, is going to be my coefficient of x, and that's going to be 3, and my b value is going to be the number that's being added or subtracted on. In this case, that's 4. Now remember, the y-intercept is actually a point on the line, and it's written in xy format, and that would be 0, 4. And the reason this first number is 0 is because, remember, it has to be touching that y-axis, which means we don't want any left or right movement. I want you to pause the video, try examples 2, 3, and 4. Press play when you're ready to check your answers. So one thing to notice about examples 2, 3, and 4 is that all of these examples have y already isolated. So that means they're in slope-intercept form and they're ready for us to identify the slope and the y-intercept. On example 2, the slope is my coefficient of x, and so that's negative 3. My b value is 2. As an ordered pair, that would be 0, 2. On example 3, my coefficient of x would be my slope. That's 5. My b value is negative 3, and the reason it's negative is because it's being subtracted. And as a y-intercept as a point, that would be 0, negative 3. On example 4, my slope is negative 1/2. Don't forget that negative. My b value is negative 7, and as a point, the y-intercept would be 0, negative 7. Now on examples 5 and 6, the main difference here is that y is not isolated. So I'm going to have to get y isolated before I can say the slope and the y-intercept. So on example 5, I notice that the thing that's stopping y from being isolated is 3. And so I'm going to start by dividing both sides by 3. Now when I divide on the right, I want to remember to use the beans. So 12 is getting divided by 3, but 3x is also getting divided by 3. So as a y equals equation, this would be 4 plus 1x. Now I'm ready to identify my slope and my y-intercept. Now my slope is always the multiplier of x, even though it's not written in that order. So my slope in this case would be 1. And my y-intercept is always that number that's being added or subtracted. And so in this case, that number would be 4 for my b value, for a y-intercept of 0, 4. You're going to try example 6. I want you to pause the video. Remember that first you need to get y isolated. Use reverse PEMDAS. Once y is isolated, then you can identify your slope and your b value and your y-intercept. Press play when you're ready to check your answers. So on this example, the first thing I did to get y by itself was to subtract 8x from both sides. Then I divided by 4 using the beans. 16 divided by 4 was 4. Negative 8x divided by 4 was negative 2. My slope is always the number that's multiplying x, which in this case is negative 2. And my b value is that other number, which in this case is positive 4, for a y-intercept of 0, 4. Now that we know how to identify the slope and the y-intercept from an equation, we're going to use that information to graph our line. So the first thing that we want to do is we actually want to make sure that it's in slope-intercept form first. So in order for this to work, y needs to be isolated. Then I've got those two pieces of information that I'm going to be pulling out. I'm going to be pulling out the m and the b value. Slope tells me how steep a line is, but the b value is actually a point on that line. And so that's where we're going to start. We're going to start at the y-intercept. So that means our first point that we graph is going to be somewhere on the y-axis. Our only choices are going to be to move up or down. So let's do this step by step, and then we'll come back and fill in the rest of the steps as we go. So if I look at example 7, the first thing I'm looking at is making sure that y needs to be isolated. And in number 7 it is. And it tells me to start at the y-intercept. So I'm going to write down my information. My slope is my x multiplier, and so that's 2/3. And my b value is the other number that's being added or subtracted, and so that's my -1. And so it's asking me to start at the b value of -1. So that's saying it's going to cross the y-axis at -1, which is right here. So I'm going to put a point there. That's step 1. Then it says from the y-intercept, we're going to rise, then run according to the slope. And we want to always pay attention to the sign of our slope, positive or negative. Because remember, positive slopes are going uphill and negative slopes are going downhill. So our slope should match when we're done, our line should match when we're done, the type of slope. I also want to make sure my slope is a fraction so I can see both rise and run. And so in this case, my slope is already a fraction, which means my rise is 2 and my run is 3. So this tells me to go from the y-intercept, so I'm going to start with my pencil on the y-intercept. I'm going to rise 2, 1, 2, and I'm going to run 3, 1, 2, 3. And then I'm going to put another point there. And I'm going to do that just a bunch of times. That's what this last one says. Plot multiple points in both directions, and then connect with a ruler. So I'm going to keep going up 2 over 3, rising 2, running 3. And then I run out of room there before I would go off the graph. So the next thing I'm going to do is I'm going to go back to my starting point, and instead of rising 2 and running 3, I'm actually going to go down 2 and backwards 3. And you can see how that would actually keep me on the same line. So down 2, left 3, down 2, left 3. Part of the reason I'm doing this and not just connecting 2 points is that when I now go to connect with my ruler, which I don't have one on Explain Everything, so I'm doing the best I can, the more points that I have, the easier it's going to be to connect them precisely. Let's look at our next example. So on example 8, if I follow my steps outlined above, the first thing I recognize is that y is isolated. So first I'm going to actually write down my information. So my slope is my x multiplier, so that's -2, and my b value is going to be that number that's being added or subtracted on the end, and so in this case it's 5. Then it tells me that I'm going to start at my y-intercept. So my b value is 5, that means it's going to cross the y-axis at 5. So I'm going to go up 5. 1, 2, 3, 4, 5. That's always going to be my first point, is always going to be on the y-axis. Now I've got my slope, which is -2. Now the problem is I need to rise and run. So right now I have a rise, but I don't have a number on the bottom, where over here I had a numerator and a denominator. So the way that I can make any number into a fraction without changing it is just always by putting it over 1. So if your slope is already a fraction, great. If not, you can just put it over 1 and it won't change it. So that means my rise is -2 and my run is 1. So from my y-intercept, that's going to be my starting point. I'm going to rise down 2 because it's negative, run 1. Keep in mind that this 1 is a positive number. So I'm going to rise down 2, run 1. Down 2, run 1. I'm going to do that as many times as I can get it to fit on the graph. So down 2, run 1. And then if I come back to the starting point, I want to put some points over here in this direction. So instead of going down 2, I can go up 2. But then I want to go backwards 1. And now I have enough points to connect with my ruler or the edge of something straight. And I've got my line. Now if you were thinking back at the start that because it was negative you might go down and to the left, keep in mind if you did that, your slope would have been an increasing slope when connected. And I know that I want to have a decreasing slope. So I always want to make sure my line reflects the type of slope that I have. So you're going to try examples 9, 10, and 11. Make sure you're starting at your y-intercept value and then rising and running where your slope tells you to go. Pause the video, press play when you're ready to check your answers. So the first thing to check on number 9 is just to take a look at your line and make sure that your line has a decreasing slope. So as you read it left to right, it should be going downward. One of the things that's confusing on this one is that our slope is negative, so that's why I know it's a decreasing slope, but it's kind of in the middle here of the 3/5. So one thing I like to do is I like to take that negative symbol and just put it with the rise. So then when I start at my y-intercept of 2, then I'm going down 3, negative, but then running 5. If both of these numbers were negative, a negative divided by a negative is a positive, and if I had gone down and to the left, that would have made my line an increasing slope. So when you see a negative slope, it's important to know that the negative symbol is only going with either the rise or the run. Usually the easier way is to put it with the rise. So starting at up 2 on the y-axis, down 3, run 5, and then I ran out of room, and so then I did a point in the other direction, up 3 and left 5. On example 10, my y-intercept was -2, so I'm starting down 2. My slope was 3, so I made that into a fraction by putting it over 1. Rise 3, run 1. Rise 3, run 1, did that, and then came back to the starting point and went in the opposite direction. Down 3, left 1, and so now I have a line with an increasing slope. On example 11, I started at my y-intercept value of -3. My slope was 5, so I put that over 1, and then I rose 5, ran 1, rose 5, ran 1, and I didn't have any room to do it in the other direction. When I look at example 12, I see that the difference here is that y is not isolated. And so my first thing would be to get y by itself by subtracting 2x from both sides. And so this means that y will equal 3 minus 2x. And now my slope is still going to be my number that's multiplying x, which is going to be -2. And my y-intercept, or my b value, is going to be the number that's being added or subtracted at the end, which is going to be 3. So in this case, I'm going to start my graph at 3 on the y-axis. And then my slope, if I think of it as -2 over 1, I'm going to go down 2, run 1, down 2, run 1, down 2, run 1, over and over, and I'm going to do some in the other direction as well. So when I connect these points, I should end up with a line with a decreasing slope because my slope was negative. Try examples 12 and 13. Pay attention to the sign of your slope. Pause the video, press play when you're ready to check your answers. On example 12 and 13, y is already isolated, so I'm ready to identify my information. Here my y-intercept is -2, and then my slope was 5/2, so rise 5, run 2. I only had room to do it once in this direction, and then I was able to go down 5, left 2. Reading my line, it has an increasing slope. On example 13, I started at my y-intercept of 3, and then again with my negative, I want to make sure my line is decreasing as I read it left to right. So I took that negative symbol and I just attached it with the 1. So I took that to mean rise down 1, run 2, down 1, run 2, and then I did some in the other direction as well. Again, make sure you're connecting with a ruler or something straight. I just don't have that on Explain Everything right now. So here's 2 more examples where we're going to graph, but y is not isolated yet. So let's take a look at one together, and then I'll have you do example 14 on your own. So on example 13, y is being bothered by 2, which is multiplying it, and 4x, which is adding it. So I'm going to get rid of these in reverse PEMDAS order. I'm going to start by subtracting 4x. So 2y equals 8 minus 4x. And then I need to divide by 2. Make sure to do my beans. And so then y is going to equal, I'll have to write it down here, 8 divided by 2 is 4, minus 4x divided by 2 is 2x. And so then that means my slope, remember, always goes with the x, is going to be -2, and the y-intercept, which is the number that's being added or subtracted, would be +4. So I'm going to start my graph at +4, and then since my slope is -2, I'm going to think of that as -2 over 1. So rise down 2, run 1, down 2, run 1, and I can see as I'm creating this line that the line is going downward from left to right. And so I've got a line with a decreasing slope. Pause the video to try example 14. Be sure to isolate y first. Press play when you're ready to check your answer. So in order to get y isolated, we first subtract 3x from both sides, then divide by 3. 9 divided by 3 was 3, and -3x divided by 3 was -1. So my slope is -1, and my y-intercept was 3. I started at 3 at the y-axis, and then thought of this as rising down 1, running 1. So down 1 over 1, and then did some in the other direction as well. As I read this line, it has a decreasing slope, which is what I expect because the slope was -1.